Greetings to each and everyone, and this is Group 3. Today we are going to tackle about problem solving and reasoning, discussing the mathematical proofs, problem solving that includes problem solving patterns, and recreational problems. Today's topic is entitled The Proof of Real-World Problem Solving and Reasoning, with the theme Problem Solving and Reasoning Key to World Success. And these are the objectives. First, understand the mathematical proofs of real-world problem solving and reasoning through mathematics. Second, utilize the use of different types of reasoning in justification of statements and arguments about math and math concepts. Third, utilize knowledge about problem solving and reasoning. And this is our group's presentation's flow or conceptual framework.
Mathematical proofs. A proof is a series of logically ordered statements of true facts. It is a sound mathematical justification that conclusively proves the veracity of a particular claim. To prove this, the following may be used as reasons. A. Given information, example, hypothesis. B. Definition and undefined terms. C. Algebraic properties. D. Postulates of geometry. E. Previously proven geometric conjectures or theorems.
Now, let's discuss the algebraic and geometric proofs. An algebraic proof shows the logical argument behind an algebraic solution. You are given a problem to solve and sometimes its solution. If you are given the problem and its solution, then your job is to prove that the solution is right. Before we proceed, the following are the important properties of algebra: reflexive, symmetric, transitive, substitution, and distributive. Addition properties of equality or APE. Example: if a number of x equals a number of z, then a number of x plus and minus a number of y equals a number of z plus minus a number of y. Multiplication properties of equality or MPE. Example: if a number of x equals a number of z, then a number of x and y equals a number of y and z, or a number of x over a number of y equals a number of y over a number of z.
Next is the geometric properties. The following properties may be used to justify proof or some mathematical statements. First is the reflective property or REF. The given is AB is congruent to CD, and the statement is AB is congruent to AB, and CD is congruent to CD. Second is symmetric property or SYM. The given is AB is congruent to CD, and the statement is CD is congruent to AB. Third is the transitive property or trans. The given is AB is congruent to CD, CD is congruent to EF, and the statement is AB is congruent to EF. Fourth is the addition property of equality or APE or APE. The given one is AB is congruent to CD, and the statement is AB plus minus sign EF is equal to CD plus minus sign EF. Given number 2, AB is equal to CD and EF is equal to GH. So the statement is AB plus minus sign EF is equal to CD plus minus sign GH. Fifth is the definition of congruent segments or DOCS. The given is AB is congruent to CD, and the statement is AB is equal to CD or vice versa. Sixth is the definition of betweenness or DOB. Looking at the given figure, statement AB plus BC is equal to AC. Lastly is the definition of midpoint or DOM. Looking at the given figure, the M is the midpoint of AB. So the statement is AM is congruent to MB.
Polya's four-step in problem solving. Nearly 100 years ago, a man named George Polya designed a four-step method to solve all kinds of problems. Learning to solve problems is not a difficult task. However, it requires you to think analytically, critically, and creatively.
But how do we write mathematical proof? Proofs can be written in a variety of ways. Top-down or deductive reasoning and bottom-up or inductive reasoning are both possible. It may be a professional or casual process. Problem solving. It refers to the mathematical tasks that have the potential to provide intellectual challenges for enhancing students' mathematical understanding and development. Let's talk about mathematical problems involving patterns. Our lives are filled with many difficulties, but some of them are not so serious because of the answers are readily apparent, such as when the information or data presented shows an existing pattern where the remedy shall begin and proceed. In order to determine the accurate and realistic value, this pattern might be used as a reference. We must first solve problems in order to build mathematics, which is an active human endeavor. In many ways, pattern aids in issue solving and confirms an immediate solution. Always keep in mind that you should concentrate more on the disparities between the numbers and find the value that unifies them all and indicates the logical order. Remember, sequence is a set of numbers in a specific order. Example, 1, 2, 3, 5, 8, and 13.
Let's have an example. Number 1. Find the next term of the sequence 7 over 2, 19 over 2, 31 over 2, 43 over 2, and 55 over 2. First thing to do is to understand the problem. Read and understand the problem. Given, required, we are going to find the next number in the sequence. Second, devise a plan. Come up with some strategies for solving the problem. First term is 7 over 2, and the second term is 19 over 2 equals 7 over 2 plus 6, and the third term is 31 over 2 equals 19 over 2 plus 6, and the fourth term is 43 over 2 equals 31 over 2 plus 6, and the fifth term is 55 over 2 equals 43 over 2 plus 6. Third, carry out plan. Solve the equation you have set up and observe analytical rules. As we can see in the sequence, their common difference is 6. Therefore, 6 equals 12 over 2. So, the next number in the sequence is 55 over 2 plus 12 over 2 equals 67 over 2. Looking back as the last procedure, find a way to check your answer, preferably using a different method than what you used to solve the problem. The answer of the sequence as the next term is 67 over 2, and this completes the sequence.
Now, let's talk about the recreational problems using mathematics. Mathematics that is done for leisure or as a hobby is referred to as a recreational mathematics. Typically, it refers to games and puzzles that have a mathematical theme, though the phrase can refer to other content as well. Instead of using complex mathematical ideas, recreational mathematics typically relies on general logical and lateral thinking abilities. This allows the average individual to at least comprehend and appreciate a recreational problem and its solution. People's appreciation of mathematics as a whole can also grow as a result of creative challenges. Let's have here an example. The Magic Box. One highly popular math game is Magic Squares. Example. As you can see in this box, we have the first 3 digits in the top row, which are 2, 7, and 6. And if you add these 3 digits, you will have the sum of 15. The same thing with the middle row, which has 9, 5, and 1. And if you add the numbers, you will have the sum of 15. Same goes with the bottom row, 4, 3, and 8. Adding the numbers, we will have the sum of 15. But the most interesting part is that looking at it by column, we have the first column on the left side, we have numbers 2, 9, and 4. If we add these numbers, we will have the sum of 15. On the middle column, we have 7, 5, and 3, we have the sum of 15. As well as the right column with the numbers 6, 1, and 8, we will have the sum of 15. And that's an example of recreational problems using mathematics.
Now that we are done discussing some parts of problem solving and reasoning, I hope that you have learned something today. That's all for today. Thank you.